Hello and welcome to Algebra 1. Today we're going to do 3.5, which is working with sets. The first thing we need to learn is that what a set is. Here's sets, and those are just a group of numbers that belong together. The examples of what a set can mean, a set could be like our class's favorite numbers. So that'd be an example of a set. We found everybody's favorite numbers and put it together in a group. Or it could be the days. A set could be the days we have school. Or a few others. Right? But a set is just a group of numbers that belong together. So first thing when we talk about sets, we're going to talk about the numbers that we know so far and how they're considered a set. So let's think about the first type of number that we learned, and highlighter. First type of number we learned is called a counting number. Okay, and this is what you learn when you're little tiny and your parents are teaching you how to count. And when you start counting, you count at 1, 2, 3, 4, and you keep on counting. If you're really good, you can count all the way up, and you never have to stop. So that's called counting numbers. After counting numbers, we add the number 0. That's called natural numbers. So natural numbers are 0, 1, 2, 3, 4, and keep on counting all the way up until you get to infinity. So then we have natural numbers, which are 0 and the counting numbers. We're going to add to that integers. Integers include all the negative numbers plus 0 plus the counting numbers. So integers include -3, -2, -1, 0, 1, 2, 3, and those go forever in both directions. Now when we talk about integers, we're just talking about positive and negative whole numbers, no decimals yet. After integers, we're going to talk about rational numbers, and rational numbers are the numbers that can be written as a fraction. So that includes numbers like -3/4, -1/2, 2, all those. Now that just means that rational means that they can be written as a fraction. Let's say I had 0.0001. Can that be written as a fraction? Well, isn't 0.0001, isn't that 1 over 10,000? So it can be written as a fraction, then it's still a rational number. If we have rational numbers, we're going to have irrational numbers. Irrational numbers are numbers like pi, there's e, and then here's an example of one that doesn't have a name. Now, irrational numbers are numbers that when you write in decimal form, they never end and they never repeat. So there's no fraction made from whole numbers for these numbers. So irrational numbers are numbers that will, in decimal form, never end, never repeat. Everything together here is called real numbers. So every number that we've learned in our lives so far is part of the real numbers. So everything's a real. All right, moving on. So let's think about what does a set look like. Well, first off, we're going to talk about roster form. Roster form is where we just list all the elements in the set. So set B, so we'd say so B is equal to, and then we use these funny brackets to say that's a set. And it says is grades Mr. Davis teaches. We think I teach 9th grade, 10th grade, 11th grade, 12th grade. So we're just going to list that out. I'm going to say 9th grade, 10th grade, 11th grade, 12th grade. Oops. 10, 11, 12. That looks a little bit better. Okay, so set B is 9, 10, 11, 12. Those are the grades I teach. How about on example 2? So set H is the set of all integers, all right, so integers are positive and negative whole numbers, greater than 1 but less than 7. Okay. One thing I want to point out right here is that they do not say or equal to, right? So this is not including 1. But what's a number greater than 1? That's an integer. 2 is greater than 1. 3 is greater than 1. 4 is greater than 1. 5, 6, but we're not including 0 because it just says less than, doesn't say less than or equal to. So that's my set H. And that's roster form, just setting up a explicit list. All right, here's another example of what sets look like. This one's called set builder notation. And these are instructions on how to find all the elements of the set. Because some of them, let's look at example 3, it says set of all even numbers, even integers. So if I was going to talk about even integers, that's going to take a long time, right? I mean, I could start, if I was doing roster form, I could go 2, 4, 6, 8, but how long would I have to write? Would I ever end? No, I wouldn't. And I didn't even talk about the negative integers yet. So doing it in roster form sometimes is not really feasible. All right? So that's why we're going to use set builder. Here we're going to, when we use set builder, I'm going to say this notation right here. With this, what I wrote in red says X is an element of the set. And it's kind of like if. So what this tells me is this says if, and now what we're going to do is we're going to write down some, in green, we're going to write down some instructions. Right. So we're going to give instructions to tell somebody how to find all even integers. Right. Well, what I'm going to do is I'm going to say, you can do this a few ways. You could write out all even integers. What I'm going to write is I'm going to write X's element set, if we take 2 times X, or X, it's an integer. So now I know that if I have X as an integer, so let's think about the first integer, which is 1. 1 times 2 is 2. Is 2 an even integer? I think so. What about if I use -1? -1 is still an integer. If I take -1 times 2 is -2, an even integer? Yep. So that's what we're going to try to do. Now, you could have wrote something like this, what we did in green, or we could even write something like this where I'd even accept something like this if you can't think of the other one, right? Just writing it out in standard English. All right, so erase some of that so I can get started on number 4. It says all real numbers between 5 and 15. Now, if we talk about real numbers, those are all the type of numbers we learned so far. So I can't just list out like, 6, 7, 8, 9, 10, so on, because of, 5.5 is still a real number. 5.55 is still a real number. 5.55. So there's an infinite amount of numbers between 5 and 15. So I cannot possibly write them all out. So what I'm going to do is I'm going to say X is an element of the set. And then because I want X to be between 5 and 15, we can do that with some mathematical symbols, right? I can say 5 is less than X, which is less than 15. Doesn't that tell me X is between 5 and 15? And then we might say X is, now I'm going to use a, ooh, that was an ugly one. Let me try to do that a little bit better. X is, there we go. And then that funny R right there does not stand for the Houston Rockets, but it stands for a real number. That's just shorthand to write real numbers, like kind of 2 legs on that R. Okay. So those are set builder notations. Oops, too far. Number 5, we're going to solve this inequality and write the solution in set builder notation. All right, so we should know how to solve this so far. So if I'm going to get m by itself First thing I'm going to do is 1 minus 12. Negative 8m is greater than or equal to, I think that gives me 48. Divide by negative 8. Divide by negative 8. What happens? What's different when you divide by negative? We flip that sign. 8 divided by 48 divided by negative 8, I think it's negative 6. So again, m is less than negative 6. So if I want to write this in set builder, funny brackets, x is an element of the set. If, I guess, well, hold on. Yeah, we're not talking about x, right? We're talking about m's. There we go. M is an element of the set if m is less than or equal to negative 6. Set builder notation. All right, subsets is a set made from a set. So if I look here, I have set A, which is the numbers between 1 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Set B is all the even numbers. Now if we look, all of B's numbers are inside of set A, right? So because of that's true, set B is a subset. There's no extra pieces, there's no missing pieces. You don't have to use all of the elements, but you just use some of them. We say B is a subset using this, like, it's kind of like a less than sign, but it's kind of curved. That means the set is less than A, but everything in B is also an A. And so it's a subset. So if we look right here, number 6, we want to list all the subsets of A, B, C. So I want to think of what list can I make using only those 3 elements. Well, the first one is that one. Now let me ask you, did I use, in my red writing, did I use any extra elements other than what's in the first list? No. So it is a subset. So that's an example. That's the only subset with 3 elements in it. Let's try a subset with 2 elements in it. How about AB, BC, and AC. An order doesn't matter, so the set AC is the same thing as set CA. How about the sets with just 1 element in it? A, B, and C. Wow. C. Now, the last one we're going to do is we could do one that looks like this. What's in this last set? Is there anything in there? We call that the empty set. And the empty set is always a subset of a set. Empty set. Sometimes you might see that same empty set written as like a 0 with a line through it. And those two mean the same thing. All right, but empty set. All right, universal set is a set of all possibilities. The empty set is a set with no elements in it, which we just talked about. The complement of a set is the other half of the universal set. And I think it might be easier if we look at the next example and then go from there. So example 7, the universal set and set A are defined below. What are the elements of the complement of A? So the universal set is pre-algebra, algebra, geometry, algebra 2, and pre-calculus. So we probably think of the universal set as being the math classes offered at Stanfield Secondary School. Set A is pre-algebra, algebra, and algebra 2, or the algebra classes. Okay? What we want to know is what is the complement, let me call this A prime, what's the complement of A, which means what am I missing from the universal set? So if I look, let's see, I got pre-algebra, I got pre-algebra. I got algebra, I got algebra. I got algebra 2, and I got algebra 2. But what 2 pieces am I missing, right? I'm missing geometry and I'm missing pre-calculus. So that's going to be my complement. My complement's what's the other half to get the whole universal set. So my complement's going to be geometry and pre-calculus. And that's complement of the set. All right, good luck and have fun.